Section 8.2, Coulomb's law. So in the last chapter we talked about how there's a force that exists between two objects with electric charge. And this is the force that holds together atoms. The force of gravity exists between two objects with mass. The electric force exists between two objects with electric charge. However, unlike gravity, gravity is always attractive. It always pulls objects together. This is because the masses of objects are always positive. Unlike gravity, the electric force can attract or repel. If you have like charges, the force will cause the objects to repel. They'll push away from each other. If you have unlike charges, so a plus and a minus, the objects will attract. And that electric force is what holds together the atoms. In this case, very similarly to gravity, the force is proportional to the charge of each of the objects, which we write with a Q, and inversely proportional to the distance between the object squared. So what this means is that if the charge goes up, the force goes up, and if the distance goes up, the force goes down. Much like the force of gravity, the electric force has a constant associated with it. We call this the electric force constant, which is 9 times 10 to the 9 newtons meters squared per coulomb squared. So the electric force was first determined by French physicist Charles Augustin de Coulomb. So when we talk about electric charge, we name the units for electric charge after this man, so we call them coulombs with a capital C. 1 coulomb of charge is actually a really big amount. So 6.25 billion electrons. Generally, electric charges on objects are on the order of micro or nano coulombs, so 10 to the minus 6 or 10 to the minus 9. And the charge on just a single electron is something times 10 to the minus 19 coulombs. And again, it's this electric force that holds the electrons to the nucleus inside of an atom. The last thing that's important that I want to point out in this chapter, because we'll discuss it just a little bit more later, is the idea of what's known as charge polarization. So sometimes electrons aren't necessarily removed from an object so much as they're moved on an object. And when we move the electrons in an object, we essentially can arrange the charges of that particular object. For example, if you have something where you move all the electrons to one side, well, that one side has a bunch of electrons on it. So that one side of whatever object it is going to be negatively charged. And because all of those electrons moved over to one side, the opposite side would be positively charged. So even though there's no net change in the charge on the object, with the electrons on one side and the protons on the other, each side of the object has a net charge. So when we arrange charges in this way, we refer to it as charge polarization.